In this example, we want to solve the system where first equation is x minus 3y is equal 4 and the second equation 5x minus 15y is equal 10. So we'll use elimination to do so. We'll multiply first equation by negative 5 to match the coefficients of x. So if we do that, the system becomes negative 5x plus 15y is equal negative 20. The second equation will be intact because we already have right coefficient of x. And we'll add the equations side by side. If we do that, then x variable terms with x will be eliminated, by also terms with y will be eliminated. So on the left hand side we'll get 0. On the right hand side, however, we'll get negative 10. So we'll get the equation 0 is equal negative 10 by doing something that we are allowed to do to the system. This equation obviously is not true, no matter what values of x and y are used in above equation. So what does that mean for our system? Let's take a closer look at the equations. The first equation is x minus 3y is equal 4. If I write this equation in a slope-intercept form, I will have 3y is equal x minus 4, and by dividing by 3 I will have 1/3 x minus 4/3. The second equation is 5x minus 15y is equal 10. And if I write this equation in a slope-intercept form, I will have 15y is equal 5x minus 10, the first step, and now dividing by 15 we'll get 5 over 15x minus 10 over 15, which gives me y equals, after simplification, 1/3 x minus 2/3. So if we look at those two equations, you can notice that they have the same slope, 1/3, and they have a different y-intercept. And that means that those lines are parallel. And if lines are parallel, the system has no solution. So if in the process of solving the system of equation we come across the equation like here, 0 is equal a number, equation that is not true, we conclude that such system has no solution because the lines represented by those equations are parallel.